So, good afternoon, everybody. Thank you for the invitation. My name is Paula. I'm a professor at the Department of Computer Engineering and Automation at the School of Electrical and Computer Engineering. And when they invited me for this lecture, I was a little bit in doubt if I was a right person to talk about digital health. And I will try to explain that. So my first health project was on as the beginning of my career as a professor, and it was the result of a coincidence between women meeting in a coffee shop. And so 3 women, one a medical doctor that researched with epidemias, one climatologist, and one engineer, that was me. We applied to this call from FAPESP, and we have approved a project on human health and adaptation to climate change. I am traumatized by this project because it was 2 years just to collect the data, paying Uber to make the PhD student going to a hospital far from here, and 1 more year to aggregate the data. And it was a typical data science project with a lot of exploratory data analysis. And after 3 years trying to gather the data and organize the data, in just a few months, we were able to reproduce results that were also known worldwide. That is, extreme climate events kill people. In summary, was that. As an engineer that wants to help people and to solve problems, it was a little bit frustrating just reproducing results that are not, that doesn't help anyone, right? And then with the help of a great friend that I saw here in the audience, that is Professor André Santanquet, we decided to create the first graduate discipline that are part of 4 different programs in UNICAMP. It was our Hercules job, a bureaucratic job. We created the discipline at the medicine school, at the electrical engineering school, at the biology school, more recently, right, André, at the nursing school for one of the offers. And I forgot to mention also created this course at the Institute of Computing. Actually, the course was born there. So 2 weeks after we started the classes of this discipline that was called data science and data visualization for health, we got the COVID-19 lockdown. Nevertheless, we had success to offer many times the discipline, sometimes with all the team that includes Professor Leticia Wichner, also from FAC, sometimes with only Professor André, and we combine the teachers regarding the semesters. The climate health research group is not active anymore after the pandemic. The pandemic was crucial to kill the group, and I became 99% vegetarian because I got conscious about the climate problems, and I became very anxious about the future of my children. So since then, we built our artificial intelligence for or from, you can choose, multimodal signal processing. Right now, we have 1 postdoc that's a professor from Federal University, 5 PhD students, 8 master science students, 9 undergraduate students that are part of our scientific initiation program. Important information. We are a diverse team. We have a physicist, mathematicians, linguists. We already had a plastic artist, biologists, and of course, computer scientists and engineers. We embrace the diversity because we studied information theory. Okay, also, we are fully funded. All the students are fully funded because we also have partnerships with some companies, right? Our vision as a group, we are not a digital health research group, but everything we do has application on digital health. Our vision, our goal is to solve humanity problems through intelligent systems that are capable of understanding the world beyond human capabilities by modeling any kind of sensed signal, audio, images, or any unstructured information created by humans. Important, we want systems that are able to interact with humans naturally, as peers, because we are pursuing augmented intelligence. And finally, we want intelligent systems that are capable of reasoning and learn continually. What are the main tools that we use there in our group? We use a lot of deep generative models. And deep generative models for us work beyond discriminative models, and they are more than just LLMs or multimodal LLMs, right? So our goal is to discover the originating distribution from multimodal data for multiple purposes, to better understand the underlying phenomena, because we conduct analysis by synthesis or representation learning. We reconstruct signals from partial or corrupted information. We create good enough new samples. That's very important in health because we can preserve privacy and also work with data augmentation in scenarios where we have scarcity of data. And we build artificial human mimetic agents. Why? Because we want inclusive and humanized communication with machines to promote collaboration between human and machine. So now I will present a potpourri of projects, and they are not all of them, but I will present the most recent ones. So in partnership with Professor Leticia Richner and Professor Denis Fatinato, that are also from BIOS group, we are working a lot with multispectral and hyperspectral images. This is a paper recently published from a challenge from ICAST, where we capture pictures that are, for instance, from a mobile phone, RGB pictures and an infrared image, and we try to reconstruct the full spectrum of a hyperspectral image. Why this is interesting? Because hyperspectral images work well with skin issues. So for health and also for cosmetics, there's a great interest from the industry on this type of technology. We were the third place on this challenge last year. We also work with MRS reconstruction. So in this work, we also use transformer architecture, working on spectrograms to reconstruct full signal that typically will take a lot of time to capture on a typical scanner. So with less snapshots from the scanner, we can reduce the time of the patient inside the machine, and we can reconstruct the signal of interest. We also work with text-to-speech synthesis. So what are the digital health applications that we envision for text-to-speech synthesis? We can mention accessibility, automation, translation, device interfaces, and also education, all of them with applications on digital health. And speech synthesis for us requires the appropriate modeling of expressiveness, communication styles, and also accents that are really important in Brazil since we are a huge country, right? So it's fundamental to improve intelligibility, semantic comprehension, And also, the expressiveness, it's important to inspire trust, simulate empathy of the agent, right? To guarantee engagement. And expressiveness in speech synthesis is still an open problem, particularly for low-resource data language, such as Brazilian Portuguese, and unfortunately, also French. You are a little bit better than us, but you can also be considered a low-resource data language. We have this long-term partnership with CPQD that is responsible for transferring these technologies that we developed to the market. And I will present here really fast 3 papers of ours that, in my opinion, illustrates our trajectory, right? So first of all, we tried to build a synthesis system that was based on the training of Brazilian Portuguese proprietary data set. It was 15 hours of neutral speech and 6 hours of 3 different communication styles. And our output would be, given any text, we got realistic neutral synthesis with the voice of a unique speaker, a female speaker, and good quality prototypic communication styles. So we got neutral speech, okay, but expressive speech, not that okay, and just for one speaker. And in this journey, what if I want to change the voice, right? So we started to work with cross-speaker side transfer. So, for instance, if I have any text, 5 minutes of neutral speech recorded from anyone, including you, I can, and a reference style, I can, right now with our results, synthesize high-quality expressive speech, because we are using pre-trained models that are trained in high volume data of English and other languages. This guy is a master student that defended his dissertation last year, and he already flew away to France last week. So we already have this partnership with France. So what if I use synthetic data to augment our low-resource language to synthesize better Brazilian Portuguese audio samples? We also did that, and we got good results for neutral speech, but style is still a challenge. Okay, so now I have good results for to synthesize text to Brazilian Portuguese speech. What is next? Well, work with speech-driven scenarios. So this is a framework that we want to build. I would like to input Portuguese text and then transform it to speech and give both signals to a system that can synthesize facial animation. Pedro, that is here, is working with that, and also plans to go to France soon. We also have Costa, that is a PhD student that is working with gesture synthesis, and previous students of ours also work with that. And we also have Kevin here that right now is designing this perceptual evaluation, because we're trying to transfer the expressive gestures to a robot, to a social robot. And to finish, we are also working with other groups at our school. And in particular, we have this guy that is also French, Professor Eric Homer, that is a specialist on assistive robotics. And we just got this great result because we were the only South Global team classified for the final phase of the first challenge. That is a challenge where this robotic arm has to place a T-shirt on someone that is paralyzed. So we just, it's something that's really difficult even for a human, right? with one arm trying to put a t-shirt on a person that is paralyzed. Okay, so we are going to there on May. Please cheer for us. That's it. Thank you very much to all my students. They are the heads of our lab, and also to the multiple agencies that are funding us, and also to the companies CPQD, Eldorado, and Neuromar. Thank you.